We all absolutely love what AI can do these days, right? We've got chatbots that can write poetry, systems that can discover new medicines. It's incredible. But all of that amazing power, it comes with a hidden and very steep computational cost. Today, we're going to talk about a new architecture that might just solve that problem for good.
Okay, let's set the stage for the main event. In one corner, we have the reigning, undisputed champion of the AI world, the Transformer. It's the powerhouse behind pretty much everything you see, but it's got a big efficiency problem. And in the other corner, we have the challenger, Mamba, an architecture where the computational cost grows in a nice, steady, straight line. And trust me, this isn't just a tiny tweak, this is a totally different way of thinking about how to build AI.
So to really get why Mamba is such a game changer, we first need to understand the secret weakness of our current champion. Let's peel back the curtain on the true cost of genius. The Transformer's incredible success really boils down to one brilliant, and I mean brilliant idea. It's called the attention mechanism. Now, in simple terms, this lets the model figure out how important every single word is in relation to every other word in a sentence. It's how it gets context and nuance. It's the magic that gives models like ChatGPT their jaw-dropping abilities. But, and this is a huge but, as this quote points out, that genius comes at a cost, a massive one. The computational power needed doesn't just grow, it grows quadratically. So, what on earth does that actually mean in the real world? Well, this is where it gets kind of crazy. Look at these numbers. You feed it 10 words, it needs about 100 calculations. Okay, no big deal. But feed it 100 words, that jumps to 10,000 calculations. And 1,000 words, you're suddenly looking at 1,000,000 calculations. The analogy here is just perfect. It's like the AI has to reread the entire book from page 1 every single time it wants to understand one new sentence. It's incredibly powerful, sure, but wow, is it inefficient.
And look, this isn't just some abstract theoretical problem. This bottleneck is a real-world barrier. It makes it super expensive and painfully slow to analyze things we really want to analyze, like entire novels, massive DNA sequences in genomics research, or long streams of high-definition video. That quadratic cost is literally holding back the next wave of AI breakthroughs. So how do we fix this? Well, it's funny. Sometimes, to take a huge leap forward, you actually have to take a look back. It turns out, the key might just lie with an older, much more efficient idea that's been waiting for its moment.
So, say hello to the State Space Model, or SSM for short. Now, unlike a transformer that tries to look at everything all at once, an SSM works sequentially. It processes information one piece at a time. Think of it like this. You're reading a book, and instead of rereading every page, you just keep a running summary of the plot in your head. That little summary is the state, and that's what makes these SSMs so incredibly fast and light on their feet.
But, there's a reason these SSMs didn't take over the world before now. They had a fatal flaw. They were time invariant. What that means is the model's internal rules never changed based on what it was seeing. It basically treated the first word of a book with the same importance as the climax, which, as you can imagine, really limited its ability to do that smart, context-aware thinking that makes Transformers so special.
And this, right here, brings us to the main event. What if? What if you could get the best of both worlds? This is where Mamba steps onto the scene and just completely changes the entire game. So this is the million-dollar question, isn't it? How do you possibly merge that raw linear time efficiency of a state-space model with the brilliant, context-aware smarts of a transformer? That was the puzzle that absolutely needed to be solved. And boom, this table just lays the answer out perfectly. It's like a tail of the tape for AI. The transformer? Smart, but its inference speed is slow. The traditional SSM? Super fast, but its smarts are, well, limited. And then you look at Mamba. Fast training? Check. Fast inference? Check. Excellent long-range smarts? Check. It hits every single mark. So how in the world did they do it? The secret sauce is this really clever innovation called a selection mechanism. This is the core breakthrough. It makes the super efficient SSM content-aware. It lets the model change its own internal parameters on the fly, depending on the data it's seeing. This allows it to selectively focus on what's important and just ignore the noise. Kind of like a transformer's attention, but way more efficient. So really, if you boil it all down, it's a pretty simple but profound idea. Mamba takes the lightning-fast engine of an SSM and bolts on the contextual intelligence of a transformer. It's the hybrid we've been waiting for, getting the performance of one with the incredible efficiency of the other. Okay, this all sounds great on paper, but what does it actually mean in practice? Let's take a look at what Mamba can actually do out in the wild. This isn't just a one-trick pony, it's a challenger for all seasons.
Because Mamba combines this incredible speed with real contextual power, it's not just some niche tool for a specific problem. It's proving to be a general-purpose powerhouse that's unlocking brand new capabilities everywhere.
For example, let's talk about genomics. We're talking about DNA sequences with millions, sometimes even billions of base pairs. For a transformer, trying to process that is a computational nightmare. It just breaks down. But for Mamba, with its linear scaling, it just chews right through it, opening up whole new frontiers in biology and medicine.
Or what about video? I mean, get a load of these numbers. They're just staggering. A Vision Mamba model can process high-res video almost 3 times faster while using nearly 90% less GPU memory. Just stop and think about what that means for things like real-time video analysis on self-driving cars or drones. It's an absolute game changer.
And that insane efficiency translates directly to high-stakes fields like medicine. Mamba's ability to process these huge 2D and 3D medical scans way faster means quicker, more accurate diagnoses. For doctors, that's getting critical information sooner. And for patients, well, that can mean earlier detection and much better outcomes.
And the list just keeps going and going. We're talking drug discovery, smarter robotics, more personalized recommender systems, cleaning up noisy audio, you name it. Basically, anywhere you have long, complex sequences of data, people are finding that Mamba is a powerful and incredibly efficient new tool for the job.
So where is all this heading? Is this really the beginning of the next AI revolution? Could we be watching as a new reign begins?
Now, it's really important we stay balanced here. Mamba isn't some magic silver bullet that solves everything. The research shows that for tasks that need perfect word-for-word recall of information, something transformers are amazing at, Mamba can sometimes struggle a bit. The Transformer King still has its strengths, and believe me, the battle for the future of AI is far from over.
But just look at what's already happening. We're seeing these awesome new hybrid models pop up, like Jamba, which mixes Mamba and Transformer layers together. And the result? On the exact same hardware, it can handle an amount of information, a context window, that is 7 times longer than a top-of-the-line Transformer. That is a gigantic leap in capability.
So I'll just leave you with this final thought. The Transformer architecture gave us this AI revolution we're living in right now. It made things possible that we could barely even dream of just a decade ago. So the real question we have to ask ourselves now is, what new worlds, what new applications, what mind-blowing breakthroughs will an architecture that is not just powerful, but also blindingly fast and efficient finally unlock for us? The possibilities are, well, they're truly exciting.